so this is video 3 on waves. All we've talked about so far is the terms. Frequency period, the time it takes for a wave and how many waves takes per time. A wavelength, how long the wave is. And the amplitude, how much energy it has, how far did it get pulled back. The velocity is a combination of frequency and wavelength. And if you multiply those two together, you get how fast the thing is traveling. Well, this is going to be a standing wave, one of the concepts we talked about in the last one, or introduced. I told you about it. And a standing wave is something that happens in a string. So this would be like a guitar string. It's anchored down here and it's anchored up there. Those are called nodes. They're not going to really move. This one will move back and forth a little bit to put energy in the wave. But what's going to happen is when I turn this on, I'm going to hit this little device right here, and I'm going to like hold it, and you can hear it. And you can see that the wave is vibrating, but it's not really doing anything all that exciting. The frequency, according to this little device right here, is 9. So I'm gonna try to drop you down so you can see these devices. You're not gonna see me as much, which is fine. You don't need to look at me. But this little device is measuring 9.75, and notice nothing's happening. Now this is what's important about a wave. A wave is a way to transfer energy. So the energy is being created down here, and it's being sent through this string. Nothing's really happening. But if I begin to turn up the frequency, you're going to see something remarkable happen. It's going to get quiet. And it's going to create what we call a standing wave. Now I'm going to take the camera and I'm going to move it over here for you. You see the wave? And what's happening with that wave is it's not vibrating like it was. It's actually coming down. So I'm going to put it back here. It's actually coming down, and it's coming to there, and then it's going back up. The cool part about it is this part's not really moving anymore, and neither is that. And the amplitude is how far apart it is. Now, if you listen, and you get this just right, it'll become what we call a standing wave. Now, the wavelength is twice this long. Think about a wave. It goes from crest to crest. So this wave actually comes up this side, reflects, and goes down this side. Now, what's cool about a reflection in a wave is when it hits a more dense medium, like this stopper up here, it comes back inverted. So this wave goes up on this side and comes back on that side. Now the time it takes to get from here back down to there is the velocity of the wave. How many of these little oscillations it makes in a second is a frequency, and right now it's making about 14 oscillations per second. So I'm going to go up to about 28. Notice that there's nothing happening here. It's just a straight line again. And it's not going to form a wave until I get to about 28. And then it's going to get quiet again. And now you're going to see a full wavelength when I come up here with the screen. You see that? Boom, boom. Now in a sound wave, we call this an octave. We also call it a fundamental frequency, and then its second harmonic. In other words, the fundamental frequency is the half a wave that you saw. It's the amount of energy that makes the wave actually vibrate in this simple harmonic motion. Notice also that this is a sound wave. So this wave is traveling from this point out here through another node. See, I can hold on to that, and if I hold it right where it is, the wave keeps happening because it's not really moving right here at this center point, and the wave keeps moving. I know you can't see it very well, but it travels from here down to there and then comes back up the other way. So I'm going to bring this back over here. It starts from here, goes through this new node, and then it goes down to the bottom, and then it travels up through the node and goes back to the top. Now, this speed of the wave hasn't changed. Now you're saying, well, the wavelength changed, so the speed has to change. Well, in this case, we change the frequency by changing how fast it's rotating. So this would be a higher note in sound waves. If when you're doing sound, this would be a higher note than what was happening before. Now I'm going to do this again. I'm going to add another 14 to this. And when I get up to another 14, I get what we call the third harmonic. Now, you obviously can't see this hardly at all, but there's one, there's another one, and there's the third one. So as I move back, you can kind of see that there's 3 harmonics. Now, I might be able to even make this better. There we go. Oh, I started to lose it. Now, you know when you're playing a musical instrument and you're not liking the sound very much, that's because it's out of tune. In other words, it's not in one of these beautiful harmonics like it was a minute ago. Notice that it's nice and quiet now, and there's again the third harmonic. This would be moving at the same speed. The wavelength has changed, so that means the frequency has to change too, because the speed is determined by the medium, and the medium is the thing. Now, I know you're saying, well, wavelength is determined by medium too. In this particular case, I changed the frequency. I changed how fast this thing's vibrating. So I did this externally. Once I send that frequency through, it's going to do it. Now, if I add another 14, it's going to do it again. And again, and you can't see it because it's a really small amount at this point. Here's a really good, you can really see the 3 frequencies there, the third octave. So in this particular case, I'm creating a change in frequency. Now, we're going to take all of this stuff that I put, and this is, by the way, simple harmonic motion as well, and we're going to put it into a project that you're going to do with waves.